Hello everyone. So previously you learned about hypothesis testing and then what are the steps in hypothesis testing, how we can actually perform a hypothesis testing if we are interested to make an inference about population mean. Depending on the standard deviation is known or not known, we used either Z or we used either T. So you saw that. Now I'm interested to talk about if we have two groups and we have two population means and then the population standard deviations are known, that means we have the information. Then in that case we will again use Z. So maybe you need to write down in your cheat sheet, depending on the situation we have to decide what test we are going to do. If we have two population means and then we actually know them, the standard deviation, then we have to use Z. So you can see that this is similar to what you have did in the point estimation and then interval estimation. This is exactly the same. At first, in the statistics, you have to use the difference between the sample means and then difference between population means. Then you can use the standard deviation, that means the difference between the population standard deviation, that means the sum of them you have to use, because since we are using two population, then we have to combine them. So the combined standard error would be this one. The structure is same. Since we have two, we have to use the two population mean and then two population standard deviation. Then you can use the T table, the Z table, and then do all the steps you saw in those 7 steps. Everything will be same. So when the population standard deviations are not known, then there are two cases. Either the sample sizes are large. If the sample sizes are large, you can use that. If sample sizes, you will see that are small. Sample sizes are small, both are less than 30, then you have to go for T. Okay, so two cases we have. If the sample sizes are large, then we can go for using the Z, and then what you have to do is just take the difference between the sample mean, take the difference between the population mean, and then use the combined estimate of the standard deviation from the two samples. Okay. This is really simple. All you need to do is to use this testing. And then you can see if we don't have the sample standard deviation, then you have to calculate them. In some cases, you will see that in the assignments, the sample standard deviation is not calculated. That means you have to use the data set and then you have to calculate them. So the null hypothesis, if it is mentioned in your question, then you have to take it from the question. If it says that the difference between the population mean is 0, that means there is no difference between them, and the alternative is they are actually more than 0. That means it's one-sided. Let me draw that. Okay, so if I draw the distribution, I've drawn that, and then the critical values, you have to think about, sorry, I have to write this way. So the mean difference is 0, mu1 minus mu2 equals 0. Okay. Then the alternative, it says that it's actually more than 0. That means the critical region is in one side, only in this side, it's more than 0, and then the acceptance region is from here to here. That means the entire region on this side is actually the acceptance region, and this is the rejection region. Our job is to find out what would be the value in here. So the value over here, we need to find that. If the test statistics value we find is somewhere here, then it's actually rejecting null hypothesis. If it's found that it's actually less than this value, then we are going to say that it's not rejected. Okay. So using the, you can see that we use the level of significance 0.005, and then it's one-tailed test based on the hypothesis, and then the Z critical value, you need to find that. So Z critical value, so you know that the level of significance, that means this side, let me actually clear this, might be easier to understand. So you can see that I can draw the distribution, and then I actually need to find what would be the critical value in here. So this one, we need to think about what would be the probability value. So let's say that this is actually 0.05, this region. That means this value is 0.95. So the probability for 0.95, we need to go to the Z table and then find the value. Let's go to the Z table and let's find the value. Let's see. So in the Z table, let's say this is the Z table, and then we try to find where is the 0.95. So you can see 0.95 would be in between 0.945 and then 0.95, maybe in between these two values. So the value is 1.6, but the other decimals is 0.64, 0.05. So that means it's actually the 1.645, so in between them. So that's why the value would be 1.645. So that means 1.645, that's the critical value. And then from the test statistics, what's the value we got? 1.78. So 1.78, is it more than 1.645 or less than 645? So it's actually more than 1.78, 1.645. That means it's actually in here. That means it's in the rejection region. So we say that we are going to, based on this, we are going to reject the null hypothesis because we found it in the rejection region based on the comparison we have from these two values. And then we say that the average height of tau plus phi is significantly greater than Hamlet trees because the null hypothesis is rejected. So we go to the alternative hypothesis. So be careful when you write down all these steps, and then everything is linked. Now the question is, if we have two sample sizes, they both are small, and standard deviation or standard variance for the two population, we don't know them. Then we need to think about two conditions. One is that whether we can assume that the population variances are same or population variances are not same. So in these two options, we need to find out at first what we want to use. So if we use the two variances are same, if we find that two variances are same, how we can find that? You will see that later on we will test whether two variances are same or not using the ratio of two variances. And then you can also use the confidence interval. You will see that I will talk about it in here. So whenever we are trying to find using the confidence interval, we can also do that. And then if we find that they are actually same, then we can go for t-test. And then in the t-test, we have to use the degrees of freedom in 1 plus n2 minus 2, because you have to find the critical value using these degrees of freedom. And then we can use the sample mean difference, population mean difference, and then the pooled variance you have to use to find the combined variance. So you can follow that. So over here you will see that it shows how you can assume whether they are actually same or not. So if we do not know whether they are same or not, then we can actually find the confidence limit. Confidence limit of what? Confidence limit of the ratio of two variances. For the ratio of two variances, I showed you before how we can use the f-test. So you can see that we are going to use the ratio of two variances. The ratio of two variances multiplied by the, let me write down in here. So you have to find the f value. So in the f table, you have to find out what would be the f value. So at first, let's see that the v1, that is degrees of freedom in the denominator and the numerator. In the numerator, let's say that the v1 is n1 minus 1, that means 11. And v2 equals n2 minus 2, that means n2 minus 1, 16 minus 1 is 15. So at first we need to find out if the level of significance is 0.05, then using these two degrees of freedom, what would be the f value? So you will see the f value is so you can see that 2.52, because 1 over 2.52 and then 2.72. So I will show you how you can find that. I talked about it in the previous lesson, so you can go over that if you are not sure how to find them. But again, I will show you how you can find these f values in the table. So in the f table, we are talking about in the numerator we should be using 11, but we don't have 11 in there, so you can use the values from 10 or 12 or maybe in between. And then the denominator, we have the degrees of freedom 15. So you can see that in between them for 0.05. So for 0.05, let's see what will be the value. So you can see that it will be in between 2.54 or 2.58, maybe 2.52, something like that. So that's why in here we use 2.52, and then reciprocal of that, that means the degrees of freedom, let's say degrees of freedom 15 and 11 for the opposite. You have to go back to the table and then find out where we have the 15 here and then 11 on the other side. Maybe you have to go to the playlist. Okay, so 15 here and then 11 and then 0.05. So for that we see that it is 2.72. so that's what we used. So then we found that this is between 0.35 and 2.41. If it includes 1, if this confidence interval includes 1, then we can say that they are actually the ratio is 1, that means they are same. So you can see that it actually includes 1, this interval. That's why we say that we assume that they are actually the same. If it doesn't include 1, then we can say that they are actually different. Okay. So we found out what would be the condition for variance. Then we can say that we will use these t statistics and then the pooled standard deviation, and then if we calculate all of them, and then you can see that the t critical value, that means n1 plus n2 minus 2. So for that, we go back to the t table and find out what would be the critical region. In this case, again, you have to draw that. You can see that it's actually two-sided. So that means we will get two critical values. So using those two critical values, all you need to do is to compare with the t statistical value. So you can see the t statistical value is negative 1.53, but the critical values are negative 2.06, positive 2.06. So you have to think about, is it within this limit or beyond? So if it is within this limit, that means it falls within the acceptance region. We cannot reject the null hypothesis. So that means this one. So that's why we said there is no evidence to assume that the one brand is better than other. That means we found that they are actually similar. The other case, you can see that if we found out they are actually different, then only you need to change the pooled estimate. So you can see the standard error for the combined estimate is actually simpler, but the only thing is that the calculation for degrees of freedom is a little bit lengthy. You can use that, and then to find what would be the degrees of freedom. After you find the degrees of freedom, then you can see that what would be the critical value. Then if we find that they are not the same, and then we need to use again the confidence interval so that we can find whether they are actually same or not. If we find that they are not same, then we have to use this one. So you can see that in this example, we actually see that if we find that ratio of them, that means it doesn't include 1, so you can say there's more than 1, 1.0 to 8.79, that means it doesn't include 1. So that's why they are not the same, they're different. That's why we have to use these two formulas so that we can find the t-statistical value. But in the t-statistical value, after we find that, we also need to find the degrees of freedom, and then degrees of freedom is lengthy. You can see that we need a whole number. So whenever we find the 13.74, we cannot use it in the t table. You need to find the whole number. So we found the whole number, and then we use that in our hypothesis testing. So you can see that we at first said what would be the null hypothesis, alternative hypothesis. Be careful in here. We see that it's actually more than 6. That means it's actually a one-sided test. And then in the one-sided test, what will be the critical region? So you can see using the table, we found the critical region, and we found that the t-statistic value is 0.81. Let's compare them, and then let's find out where it falls. Let me actually draw. It might be easier for you. So if I draw, and then it's actually more than 6, that means it's in the upper region, the critical value. The rejection region, I meant. And then the critical value, that means the point in here, this value is 1.76, and then the t-statistic value 0.81 is actually smaller, and then it falls within this region. That means it falls on the acceptance region. That's why null hypothesis is actually not rejected. Okay. So now, when we have the paired observation, previously I said to you that sometimes we have the dependent information. Let's say we have data set from the same observation in 2 different years, or let's say students in our class, the midterm exam, final exam, we are collecting the sample from there, and then the midterm exam, final exam results, what we have, the grades, they are dependent because they are coming from the same individual. So it's the same in here from 2 different years, but the observations are same. That's why what we have to do, we have to take the difference between them. The values we have to take the difference between them, and then we have to use that in our test. So that's what you can see, that we found the average of those DI, the difference we found, and then the standard deviation of the difference we found, using the sample standard deviation, that means using these values only. So you can see that only these values you have to use, and you have to calculate the standard deviation of these values, and then you have to take the square, divide by root over n, the sample size, then you can directly use that. So we say that the difference between them is 0 in the null hypothesis. Alternative hypothesis is not equal to 0, that means two-tailed, that means the critical region is on both sides. And then we found from the t table it's these two values, and then using this test statistic we found that it's 2.77. Then you have to think about, is it within these two values or beyond these two values? We found that it's actually the 2.77. You can see that it's more than these values. That means it's not within the acceptance region. That means it's actually falls within the critical region. Null hypothesis is rejected. That means they are not the same, but we do not know which one is larger, which one is smaller, right? So that's why we say that it's in the critical region and significantly. So since we use the first one, we have to say that we use the first one minus second one, then we say that the average growth in between them is significantly higher in one of them. Okay. So whenever I will give you some in the assignment or in the exam, if I give you a data set, then you have to think about, are there any dependencies going on? Are they paired data or they are independent? If they're independent, then you have to use the previously what I showed you. But if they are dependent, then you have to treat them as a paired data, and then you have to use this test statistic. Okay. Okay, so that's about the testing the two means whenever standard deviations are not known. And then how about the sample sizes? How about whether the data set is actually dependent? Based on that, you have to decide on what type of testing you have to do, and then what would be the critical region, and then test testing. So that's it. Thank you.